And welcome to another fun-filled unit in grade 10 pre-Cal math. We're starting here with unit 3, factors and products, and we have our first lesson, which is 3.1, factors and multiples of whole numbers. So a few things we want to talk about before we get going is what exactly a factor is. And you think back to grade 9, factoring is a number that divided the integer exactly. So if I have the number 10, you ask yourself, what numbers can multiply together to give me 10? You get the first one off the bat, real easy, 10 and 1. You can also have 2 and 5. And those are the only numbers that multiply to be 10, so we'd call them the factors. Now we also want to talk a bit about prime numbers. Now remember what a prime number is, a little definition here. A prime number can be divided evenly only by 1 and itself. So for an example of 10, it's not a prime number. You've got 1 and 10, that works nice, but you've also got 2 and 5. Let's think of a number like 13. In number 13, we've only got 1 and 3 that equal 13. There's no other combination, so we call number 13 a prime number. So now we kind of bring these together, and we want to get the prime factor. So the prime factor are prime numbers that divide the integer exactly. So I want to think of all the numbers out there that are prime that will multiply to give me 10 or 13 or whatever I want, but only the prime numbers. So we can do this two ways. We can do this as method 1, which is the tree method. It's my personal favorite, but also show you the method number 2, which is the division method. Both ways work fine. Figure out which way works best for you. As long as you can show the work, get the answer, we're good to go. So the question now is, write the prime factorization of the number 360. So let's start off with the tree method. So for the first tree method, I'm going to write down the number 360. So 360. And now I just simply ask myself, what two numbers can multiply into 360? It doesn't matter which two, as long as they work. So for me, the easy ones that I see right away are the number 36 and the number 10. Now we call this the tree method because I'm making branches every step I go. So I took 360, the first branch was 36 and 10. And now we take each of these numbers and ask yourself, can I branch those off? Are there two numbers that multiply to give me 36? And there's a whole bunch. I'm just going to pick two of them. My favorites are 6 and 6. And now I'm going to the number 10. What two numbers multiply to give me 10? Well, I've got 2 and 5. And I'm going to continue working down my tree, adding more branches until I only have prime numbers. So is 6 a prime number? No, it's not. So I get 2 and 3. Another 6 gives me the same prime numbers of 2 and 3. 2 is prime, so I can leave that alone. And 5 is prime. I can leave that alone. So I now have the prime numbers calculated. I'm going to write them out, starting with the smallest one first and going to the biggest. So I've got 2 times 2 times 2 times 3 times 3 times 5. Check, 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 and check. Got them all. Perfect. But now I would like to simplify these a little bit. 2 times 2 times 2, I can express that another way. I could go 2 to the power of 3. 3 and 3, I can go 3 squared. And I've only got one 5, so I'll just simply put down a 5. Now, if we remember from grade 9, we understand there's a 1 there, but we don't have to express 1s when we're talking about exponents. So the prime factorization of 360 is 2 cubed times 3 squared times 5. So let's go back up and try the second method, method 2, which is division. Now if I get it right, I should get the same answer. Let's take it out. So I start with my number, 360. And I want to start by dividing by the smallest prime that I know, which in this case is 2. 360 divided by 2 is 180. I drop down 180 to my next line, And again, start by dividing by the smallest prime I know, 2. 180 does divide by 2, which gives me 90. Drop 90 down. Is 9 divisible by 2? Yes, it is. So I get 45. Drop 45 down. Is 45 divisible by 2? Well, no, it's not. So I go to my next prime, which is 3. Is 45 divided by 3? That works. Gives me 15. Now, if I've done this right, my 2 should be done. But we'll keep going. I bring down the 15. Not by 2, but it is by 3. Gives me 5. Bring down the 5. 5 is not by 2, 5 not by 3, but 5 is divisible by the next one, which is 5. And I get down to a 1. That's kind of my goal here, to get this number down to a 1. So I went divided by 2, by 2, by 2, by 3, by 3, by 5. So it looks like it's going to work out perfectly here. Just write down my primes, 2, 2, 2, 3, 3, and 5, and I'll simplify it. There's 3 2's, 2 cubed, there's 2 3's, 3 squared, and 1 5. 2 cubed, 3 squared, 5, 2 cubed, 3 squared, 5. Looks like they work. Excellent. So prime factorization, break up your numbers into your primes, combine them in the end. Let's turn our page and bring in another concept, the GCF. GCF, of course, is greatest common factor. So you're going to take two numbers and you're going to factor them. Get all the numbers you can that multiply together to give you the factor. And then with the greatest common factor, choose the biggest one. So again, we got two methods here, the rainbow method and the prime factors method. Let's look at the rainbow method first. So I'm going to start by writing out my number, 126. Now this method may take a little bit of space, so I'm going to try to squeeze it way off to the left of my page. I'm also going to write out the second number, 144. I'm going to draw a little solid line here to know that's the numbers I'm dealing with. So I start off, what's the first number that multiplies together to give me 126? Well, it's 1 and 126. So we call this the rainbow method because we kind of can draw a line. I'm going to switch colors on you here. Let's go to a red. And it rainbows to 126. Next number, well, is it 2? Yeah, 2. And 63. And we'll rainbow this one in blue. Does 3 go into 126? Yes, it does. 3 and 42. We'll switch to green. Does 4? Well, 4 doesn't go in, so we can leave that off. 5 doesn't go in, but 6 will. So we'll go 6 and 21. Go back to my red rainbow. 7 goes in. 7 and 18. Rainbow it with blue. 8 doesn't go in. 9 does. 9 and 14. Back to green. 10 doesn't. 11 doesn't. 12 doesn't. 13 doesn't. And I'm back here at 14. So I have all my numbers. Now there were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers that went into 126. I had plenty of space, but if you get larger numbers, you may have to write smaller, take a second line, do whatever you need to do. Now let's go to 144. So again, we start off with 1 and 144. I'm not going to do my rainbow, but you get the idea. I do know that 2 and 72 multiply to 144. 3 and 48. Now, little hint here, because I am looking for the greatest common factor, once I get the largest number to match up in both columns, I'm found the GCF. So let's go with 4. Does 4 go in? You bet it does. 4 and 36. 5 doesn't, but 6 will. 6 and 24. Still nothing matching. My 6 didn't write, I'll just write it in there. Next one, 8 and 18. Now right away you say, hey, 18's here, 18's here. I look like I got a winner. So it looks like the greatest common factor between 126 and 144 is 18. But let's just run out the rest for fun. 9 goes in. 9 and 16. 10 doesn't. 11 doesn't. 12 does. 12 and 12. So I don't have to write down 12 twice. Could if I wanted to, but the 12 appears in my list, so I'm good. The greatest number that appears in both is 18. Just curious, what other numbers did we have? Well, we also had the 1, the 2, the 3, the 6, and the 9, and the 18. So here we had 6 numbers that appeared in both lists, 18 being the greatest. Now we said there was a second method, so let's take a quick look at that one. It's called the prime factors. So again, prime factors, we just did this. We start off with 126. And what numbers go into 126? Well, I know 2 and 63. They work pretty good. 2 is prime, so I can leave that alone. What goes into 63? Well, I know 9 and 7 do, so let's use 9 and 7. 9 is not prime, but I can break 9 into 3 and 3. 3 and 3, they're both prime, so I'm good. 7 also prime, so I can leave that alone. So my prime factors are 2 times 3 times 3 times 7. Now for this method, I would not suggest combining the 3's. Just leave it alone at this point. Let's go into 144. And what numbers go into 144? I like using small ones just because it's a lot easier to work with. So I'm going to go with 2 and 72. 2 is prime, so let's go to 72. Another small one is 2 and 36. 36, let's try 2 and 18. 18, we know we can go to 2 and 9. And 9, we can go to 3 and 3. So we got primes as 2's and 3's. And again, it doesn't matter which two numbers you use to multiply into 72, you will get the same answer in the end. So what we have to do now is take the first number of 126 and list its prime factors. So we get 2 times 3 times 3 times 7. And 144, we get 2 times 2 times 2 times 2 times 3 times 3. Double check, make sure you haven't missed any. Perfect. So now what you want to do is you want to find prime factors that are common to both lists. So I'm going to get a green highlighter here. I can see there's a 2 in this list, a 2 in this list. There's a 3 in this list, and a 3 in this list. A second 3 in this list, and a second 3 in this list. So you're looking at what is common. There's nothing common in the 7, and there's no other 2's common, so I leave those out. So now I take my common factors and I write them down a single time. So 2 times 3 times 3. 2, 3, and 3. And when I multiply 2 times 3 times 3, I do get 18. So using the prime factors method, I get an answer of 18. Using the rainbow method, I also get an answer of 18. So again, both work. Which one do you find works the best for you? And now let's flip the page to page 3, our last one, LCM. LCM we know stands for least common multiple. So multiple is just simply taking each number and timesing it by 1, then 2, then 3, then 4, then 5. And you want to figure out which one is common to a list here of 10, 15, and 25. And again, we have two methods here, a list method and using our prime factors. I would suggest you use whichever one works best for you. So I'm going to start by writing out my three numbers, 10, 15, and 25. I'm going to draw a hard line here so I know those are my numbers I'm dealing with. And now I simply have to list the multiples until I get the greatest common. So I know the biggest number is 25, so I know both these lists have to at least get past 25. So let's see. 10, 20, 30. Now I know I'm going to have to continue this because 25 is not on my list here. So I'm going to go a little higher. Let's go 40. Let's see if 50 works. Go down to 15. I've got 15, 30, 45, 60. Okay, that didn't work, so let's go a little higher on 10. 60. I've got 60 in both. That's looking pretty good. Let's try 25. 25, 50. Well, that didn't work, so I'll continue this to 75. And 100. Maybe 100 is going to work. 60, 70, 80, 90, 100. Well, that's in my list. That looks pretty good. Let's try 15. We can go 60 to 75, to 90, to 105. Well, that's no good. Didn't quite work. Let's keep going higher. Let's go to 125 on this list. Let's go to 120 on this list. Well, that didn't work. Let's go to 150. Let's go to 135. Let's go 15 more is 150. I've got it working in two lists. Let's check my third number. 110, 120, 130, 140, 150. There we go. We found it. Continued both my all three lists until we found the one that matched. So I get 150 in this list, 150 in this list, 150 in this list. Looks like it works. So now we have one more way to try this. We're going to try it using our prime factors. So again, we list our prime factor, our numbers. 10. What are the prime factors of 10? 2 and 5. Let's go to 15. What are the prime factors of 15? 3 and 5. And then 25, the prime factors are 5 and 5. Okay, now let's write each of our prime factors and see what we get. So I start with 10. Prime factors was 2 to the power of 1 and 5 to the power of 1. Let's go with 15. Prime factors were 3 to the power of 1 and 5 to the power of 1. And 25. Prime factors were 5 squared. Now in this case, it was important to put our exponents for our next step. What we now have to do is take each of our prime factors that have the highest exponent. So in my entire list here, 2 to the 1 is the highest. So 2 to the 1. 3. 3 to the 1 is the highest. And 5. Well, I got 5 to the 1, 5 to the 1, and 5 to the 2. So 5 to the 2 is the highest. So I've taken each of my prime numbers, 2, 3, and 5, and wrote them down with the highest exponent from either of the three lists. Finally, I'm going to multiply it through. 2 to the 1 times 3 to the 1 times 5 squared. Now again, just a quick reminder that 3 to the 1 is 3, 2 to the 1 is 2, but 5 squared is not 10. It's not 5 times 2, but it's 5 times 5, which is 25. So you can actually read this as 2 times 3 times 25. And in that case, 2 times 3 times 25 is 150. So again, either method that you use gets you to 150. So you can use a list method or the prime factors. So that concludes our lesson here. We now can go to our textbook. We go to page 140, and again, quick reminder that the textbook is split up into your A questions, your B questions, and your C questions. Your choice, do any 3 of the A's, any 5 of the B's, and try 1 of the C's. And then give it a shot, see how it goes. If you have any questions, you know where to find me.